เราว่าอ่านเองครับ Okay, for this case, we talk about, I think everything is similar. It's not the same, it's similar technique. If we compare the big data, we should see distribution. That's right. But for this case, we compare between the sample one and sample two. The equation is similar. Right. For example, right, for this, if we would like to compare sample one and sample two, on population one, population two. Right. For one sample, we have x1, x2, x3. Sample two also x1, x2, x2. You have to calculate x bar one, x bar two. You have to calculate sigma one, sigma two, S1, S2 also, right? And then you use the same equation. But for this case, the distribution, for this case, we talk about the test or confidence interval for two populations with no variance. If you know variance, you use C distribution. That's right. If you know population variance, you use C distribution. And this is the C distribution. From the one sample, we use C equal to x bar minus mu divided by x divided by square root n. It looks similar. That's right. It looks similar. For this case, the mean of the sample, this is mean of the population or the hypothesis, and divided by variance 1 square divided by n1 variance 2 square, variance 2 divided by x square. If you remember for a single sample, it may be x bar minus mu divided by sigma square root n. Like this for single sample, it looks similar. It looks similar like this. And also, if we test based on different in mean, that's right, different in mean, we test based on mu1 minus mu2 equal to delta c. It may be equal right to mu1 minus mu2 equal to 0 or not, for example. Right? But if it mu1 minus mu2 not equal, this is two side test. Mu1 minus mu2 greater than mu2, one side test for upper, one side test for lower. We compare two samples. This is we compare two samples. Right. Okay, for this case, we consider in chemical to produce a formula for chemotherapy. We have to formulate the mixture of some chemical to produce the formulation for this. Formulation one is standard chemistry. This is the standard. This is a well-known formula. And then engineer or scientist try to develop a new formula. A new formula. We try to reduce the drying time. That's right. We try to reduce the drying time. For this, we have two formula. Formula one is the old one. Formula two is a new formula. We have to compare between formula one and formula two. Right. The new one is better or not, for example. The new one is better or not. Okay. From the experience, it's known that the standard duration of the drying time is 8 minutes. This is standard duration. You use C distribution. That's right. And also the variability should be unaffected by addition of a new ingredient. What does it mean? For this case, we conclude that the standard duration not affected by adding some chemical. That means the same standard duration for the old one and the new one. It's the same for this. Okay, for this we take a sample of 10 samples. Right? 10 samples are taken with formula 1 and 10 are taken with formula 2. Right? We take 10 samples for both techniques. Right? The formula 1 for 10, formula 2 for 10 also. And total is 20. Right? For N1, N1 10, N2 10. Right? And then we know the sample of the drying time for sample 1 is 171. Sample 2, the size is 2, not 1, sorry. X bar 2 is equal to 112. Right? If you know the number formula to reduce the drying time. If you know that, that's why you have to change it because 112 and 121 is come from the average from the data. That's why you have to check this is less than 121 exactly or not based on statistics. But you would like to develop a new model to reduce the drying time. But after you calculate the average drying time from a new one is less than the old one. But we would like to confirm this if statistic is correct or not because it comes from the average data. Okay. You would like to check x bar 1 and x bar 2 is different or equal. Different or equal. Okay. For this we check based on 0.05. For this case we not check based on equal, we check based on mu1 greater than mu0. You would like to check this. If you conclude that if you reject, you mean mu1 greater than mu0 is good. That's good. Because we try to reduce dry inlet. That means mu2 should be less than mu1. For this case, you can mu2 when not mu1 equal to 0 or mu2 less than mu1. You have to check at target. It's up to you. Or you can use mu1 minus mu0 equal to 0 or mu1 equal to mu2. It's many things for this. But for this case, we want to reject x0 because we need mu2 less than mu1 because the new develop. Okay, for this you use the statistic C0, right? But for variance is constant and variance is the same for new and old formulation. Okay, variance is 51. N equal. This is one side test you calculate C alpha equal to 1.6. That means for this. This is typical. You have to reject if that greater than 1.645. Like this. 1.645. Okay, and then you calculate C value, you substitute x bar 1, you substitute x bar 2, you substitute sigma 1, sigma 2, n1, n2. You get 2.52, that's greater than 1.6. That will reject. That will reject. That means a new formulation or the technique that you add some new chemical to the formula can reduce the dry inlet. That's right. Can reduce the if you got you take the new already you take x bar 1 and x bar 2 by statistic. You conclude that x bar 2 less than x bar 1. Right. X bar 2 less than x bar 1. Okay. And also we calculate the p value is 0.005. It's also less than alpha. You reject for this. Like this. And for this, there is no this technique in use. Okay, and also we can calculate the number of samples, right? Number of samples from the curve. For this case, we have to calculate from the curve. Like this. If you know D, you know beta, you can estimate N. If you know N, you know beta, you can estimate D. If you know D and N, you can estimate beta. For the curve, you need at least two properties, at least two parameters. That's right. We have three parameters. We need two parameters. Estimate another one. For this case, for the choice n equal to n1, if n not equal to n, for this you have to use this formula. And we can calculate by formula. We will use the curve, and also you can use the formula to estimate number of data. This is for two sides. You can calculate the n by calculate C alpha over 2 and C beta, and variance 1 and variance 2. This delta minus delta C. Delta means x bar 1 minus x bar 2. Now you can get x bar 1 minus x bar 2 or x bar 2 minus x bar 1 is up to you. You don't know x bar. That's right, you can do that. And also beta is calculated from it. This is the probability of this curve. You calculate this term and then you find the probability at this term. You calculate this term and then you find the probability of this term. And for one side test, this is for two side test. For one side test, you can estimate n by this formula. You can find the formula is quite similar except the alpha. For one side test, we use alpha. For two side test, we use alpha divided by 2. For this, is there some difference? Okay, you can estimate n by this. For this, we use example. If you know the delta is 10, you know alpha, and also you open from the table, you can calculate C alpha. For this case, we use the power is 90%. You substitute into value, you get about 11. That is the number of samples. Yeah. Giao lộ con trai nó là mình phải chịu lại lo. Ok, biết mình nói thành. Here for this for the next that's right. For this we test and also we can use the percent confidence interval. That's right. Previously we talk percent confidence interval before hypothesis test for symptom, but now we will talk hypothesis test and confidence interval in the same topic. Okay, how to calculate percent confidence interval for the different mean. For the different mean, for this case the control in which we can use this formulas. The confidence interval for between x bar 1 and x bar 2, this is the upper term, this is the lower term. We find this come from the formula. Like for this example, we take the pentile strength of different grades of aluminum spar. Pair of spar. Used in manufacturing of wing of commercial transport aircraft. We use the aluminum for the wing of the aircraft. From the past experience, that's right, with the spar manufacturing process and the test process, the standard deviation of pentile strength are assumed to be known. Right? We know the standard deviation, and also from that, you know, n1 equal to we sampling n1 equal to right? X bar 1 equal to 87.6 and sigma 1 equal to 2 right, for this. Okay. Do you know n1 x bar 1 sigma 1? You know n2 x bar 2 sigma 2. For this case, if mu1 and mu2, we know the two mean strength. That's right, two mean tensile strength of two grades of spar. We have two grades of spar. For this case, we would like to calculate 90% confidence interval between the difference of 1 and 2. You follow this formula. You calculate C alpha over 2. For this case, we use alpha equal to 0.1, not 0.1. Alpha equal to 0.1 based on 90% confidence interval. 0.1 for this. Alpha equal to 0.1, not 0.05. I substitute x bar 1, x bar 2, C alpha over 2. Sigma 1, sigma 2, n1, n2. And also this is the negative, this is and then you get the 90% confidence interval difference the mean of tensile strength equal to 12.22 and 13.98. What does this mean? You can compare between mu1 and mu2. For this case, the upper and lower include the positive sign. You can conclude that mu1 greater than mu2 from this. You can conclude this mu1 greater than mu2 from this. You can conclude that because mu1 minus mu2 you get both positive. If you get both negative, What does it mean? Upper and lower is negative. Mu 2 greater than mu 1, right? Because mu 1 minus mu 2 you get negative. That's mu 2 greater than mu 1. You can conclude that also. If you get negative and positive, what does it mean? If you get a confidence interval between negative and positive, that includes 0. This is mu 1 equal to mu 2. You can conclude this. Mu 1 equal to mu 2 for this. You can use the confidence interval to control this equal or not, greater than or less than for this. This also we can calculate the sample size. And this for one side test or one side is upper and lower for this. Okay, for the next, like for the case of unknown variant, for unknown variant, if we have two cases for unknown variant, we have two cases, sigma 1 equal to sigma 2. And the second case, sigma 1 not equal to sigma 2. We have two cases. This is equal. Okay, potential equal and not equal. ผมว่าไปเรื่องมันมีกี่อะไรต้องไม่ได้กี่อะไร Okay, for this, we have to get equal and not equal. For the first case, if the variance is equal, variance is equal, we will use this T distribution. We use T distribution for both, but for this we use the full estimator of sigma. Okay, we would like to get mu 1 minus mu 2 equal to delta 0. Mu 1 minus mu 2 not equal to delta 0. For this. And also we can estimate the variance for this. This is variance. Okay. For this case, we have to modify some terms, right? We did not use S. We did not use sigma. We use the full estimated of sigma. We use SP. Right? We use SP to calculate in this term, right? This is the T statistic. We have to SP. Previously, we use sigma 1, sigma 2, S1, S2, but not for this. For this, we use SP. SP calculates from this, right? SP calculates from N1 minus 1, S1 square, N2 minus 1, S2 square. Okay, you calculate SP, you substitute SP into this, and then you calculate T statistic. Right, for this case, we have to sample. Degree of freedom is N1 plus N2 minus 2. Right. For one sample, N minus 1. Sorry, for one sample, N minus 1. For two sample, N1 plus N2 minus 1. This is the degree of freedom for T2. And also we conclude about this hypothesis here. This is the no hypothesis. And alternative hypothesis is not equal, greater than or less than. This is equal. This is the same, except for SP and the formula right here. Okay, for example, for this case, we have two catalysts. Catalyst is the chemical to accelerate the reaction. You study in high school, or chemical engineering, you study a lot for that. Okay, we have two catalysts. We analyze how they affect the mean yield of chemical process. We have catalyst 1, is currently used. For now, we use catalyst 1. And we have catalyst 2 is a new one. Since catalyst 2 is cheaper. Okay, if you compare between catalyst 1 and catalyst 2, if the yield is the same, what does it mean? We choose catalyst 2 is better, right? Because catalyst 2 is cheaper. That's it. You have to design your engineer, you have to say engineer. If you get a new catalyst, and then you compare between catalyst 1 and catalyst 2, If catalytic 2 is higher yield, then we choose catalytic 2 because it's cheaper based on cost for it. We would like to check this catalyst does not change the process field. Does not change the process field. That's okay because catalyst 2 is cheaper. We get the same process field. Okay, for this case, we test in the pilot scale of not 10. The result are shown in the data. I don't take data. In minutes. Okay. We have the data from catalyst 1 and catalyst 2. Like we take sample is a sample and then we calculate the percent yield. Percent yield. We found that the average of x1, x2 is equal to the same value. It's 92.255, 92.733. I would like to compare this catalyst give the same percent yield or not. That's not. It gives the same percent yield. The next engineering solution, okay, we will use a new one. Because a new one is cheaper. We have to check it. Based on alpha 0.0. Okay, we calculate S1, calculate S2. Now you like to test different in new. That's like new 1 minus new 2 or new 1 equal to 2. Accuracy test is not equal. Equal or not equal. Right. We use the t-test. And also for this case, we know that the population variance is equal. Right? Okay, based on we assume equal variance for this equal variance. We use this formula. Right? And also we calculate the critical rate for this. This is 2.2, right? 2.14 minus 2.14. Okay. And then you calculate T0. If it's less than minus 2.14 or greater than 2.14, you reject. If it's between minus 2.14 and 2.14, you exit. And then you calculate SP first. You calculate SP first. You get 2.7. And you substitute N1, S1, N2, S2. You get 2.7. And then you substitute SP into this equation. X bar 1, X bar 2, N1, N2. You get minus 0.35. What does it mean? Minus 0.35 is between minus 2.1 and 2.1. You exit X0. Right. What does it mean? Except X0. U1 equal to U2. That's good. That's good. We need to accept because a new catalyst gives the same process yield, but new catalyst is cheaper. But the new one you have to choose catalyst 2 because it's cheaper than catalyst 1. Right. And also for this case, we calculate the p value of the yeah. Okay. Therefore, minitab we use the spreadsheet. You have to put all data in the spreadsheet. Okay, you put all the data in the spreadsheet. And for this column 1, column 2, right? Cat 1, cat 2, the name for this. Okay, for this case, I will use the summarize data. But I have no much to put the data. We prefer to stand and basic, and also for it to sample two T, right? To sample T is T distribution. So you can use the data from column, but for this I would like to use the summarize, but I have more time to put the data. The sample 1 X bar mean is 92.7 because in slide I calculate X bar X bar already, and that's already I would like to. If you put the number, you can use this data. You can use this data. Each sample is not its own product. Okay, it's like sample 1, sample 2, but for this case, we use summarize data. You have to input X bar variant. If you don't know why you use this, you add the data in spreadsheet. For instance, I would like to summarize. If our is 92.255, right? Sorry, sample size. This is about a sample size. Sample mean 92.255, 92.373. Standard deviation is 2.39. That's right. 2.98. Remember, this is not the same in slide. That's right. Because slide I have to put the number. That's right. Put the number in the sheet, and we should this. But for this, I have no one. I would like to summarize that already. Okay. For this case, we test at 95%. That's right. High frequency place, you would like to get single. You have to get this mu1 minus mu2 equal to 0 or not. For this case, we test based on equal or not equal. Okay, this is not equal. For mu1 not equal mu2, or mu1 minus mu2 not equal to 0. The same limit. Okay. For this case, mu1 minus mu2 equal to 0. This is mu1 minus mu2 not equal to 0. For this case, variance is equal. If variance is equal, you click this. If variance is not equal, you do not click this. For this case, variance is equal. Okay. This is summarize the data. N mean, standard deviation, standard mean, different mu1 minus mu2, different minus 0.0 this, and this percent confidence interval. You found that percent confidence is between minus and positive. You can conclude that these two values is the same, right? Because the confidence interval is minus sign and positive sign at the top view. You can conclude also this percent yield is equal because the confidence interval includes 0 because it's minus and positive. Or you use the p value. P value is greater than alpha. Right? P value is 0.7. Like it's greater than alpha. You can conclude that this is equal d like that. And if variance is not equal, right? Usually it's equal. If variance is not equal, the t statistic is a little bit modified. For the case, we use the variance of each sample, but t critical, that's right. Degree of freedom when you find the t value, you need degree of freedom, right? Use the t value n1 plus n2 minus 2, but this not. Degree of freedom to estimate from this. Degree of freedom to estimate from this formula. But this is when you calculate by manually, you have to. Okay, for this example, everything is the same, right? Except degree of freedom that you use to estimate T0 is different. That's right. To critical range is different. Okay. For this case, we determine the concentration of arsenic. Arsenic is like that. Okay. We would like to determine arsenic in drinking water. It also be some company that I did some arsenic to the liver, to the some reservoir or something, and then we use liver, we use reservoir with water from it to bring the tap water. You have to determine the amount of arsenic included in drinking water. Right? We have some limit. Okay, for this report from the America, Arizona Republic, for that. Arsenic concentration in ppb parts per billion, not million. Very low concentrate. It's good. What's good for your it's transfer video. For 10 metropolitan community and 10 community in rural Arizona. ในเขตเมืองโอเคชัน Okay, the data are shown this. This is the concentration in PPB, like in 10 area in the metropolitan and in the rural. This is in metropolitan. ในเขตเมืองนอกเมือง Okay, we have 10 sample, and also we know X bar 1, we know S bar, and we calculate already on this data. Right, also if we don't know the sigma is equal or not, right? Sometimes if you don't know the value is equal or not, you can plot the normal plot. I will talk to you already the normal plot, how to plot. This is I plot the normal plot of these two data. It's different slope. It indicates different sigma. That's right. It's different value. You plot the curve is different slope. If the curve like for example like this go to the same slope like this. Okay, this you can assume equal sigma. But for this case, the slope of these two lines is different. You can add to that different in value. That's right, different in value. If different in value, we use this formula. Okay. For step by step, we would like to take mu1 minus mu2. Right. mu1 minus mu2 equal to 0, or mu1 minus mu2 is not equal to 0, or mu1 not equal to mu2. For this case, we take based on 0.05. We use T0 case. Okay, for this case, we calculate degree of freedom. From this formula, you get about 13.2 reduce 13. And then you find the critical region from this degree of freedom. Right. From this degree of freedom, not n1 plus n2 minus 1, no, for this case. For this case, we use this formula for degree of freedom. And then you do this. This is what to find. It's between minus 2.16 right, and 2.1. Okay. And then you calculate T0 is minus 2.77. It's less than minus 2.16. You reject. That's right. You reject. That means the concentration of arsenic in rural and in metropolitan is not equal. That's right. It's not equal. And also the p value is less than alpha. You reject. You reject. If we use the minitab and help you to is not equal, and then you can put less than or greater than also. That's right. Less than or greater than from the CI. That's right, from CI. For this, you use the same, right? For two sample, okay. Summarize data for this case is 10, 10, 10, 10, 1, 3.5, 27.5, 7.62, 15.3. Okay. And this is the 95% below. We would like to get out of that. And for this case, we not assume equal. That's right. Previous sample we pick this, but this is not. Because the value is different. Because the normal curve of two samples is not the same slope of the normal curve. Okay, for this summarize of your technique. This is your data, you mean, and also the difference, you get the CI is negative, both negative. What does it mean? Mu1 less than mu1 less than mu2, right? Both negative. Assign both negative. Okay, but p value is less than alpha, you reject. Because from the hypothesis test, we conclude that mu1 not equal to mu2, right? And also from CI, you can conclude that mu1 less than mu2. Right? Because the CI is both negative signs. Mu1 less than mu2. What does this mean? So 12.5 less than 27.5. And one is metropolitan. Why is in metropolitan less than rural area? You have any reason? The arsenic from the rural area is higher than from metropolitan. You can talk about that. Usually in outside around the rural, that's why if you get farming, that's why it's maybe arsenic is higher than community. ทำฟาร์มทำการเกษตรนะครับอาจจะเยอะโอเคแต่ถ้าในเมืองคงมีสารอื่นเยอะมากนะครับโอเค And also we can use the size based on curve, the size based on curve, or based on millimeter, also based on millimeter. For this, I hope you try by yourself for this. And for the confidence interval, because in Excel, calculate for you in confidence example, you calculate the calculate of confidence interval by this formula, for you can calculate by using the hypothesis test because it calculate confidence interval also. You can use this thing. For this case, for equal value, you use the confidence interval based on this pool, that's right, based on this. Right. We use this SP. We use SP instead of S1 and S2. Right. And SP calculated by this. I talked to you already. Like that. And for not equal value, you use S1, S2, but degree of freedom is this. Right. Degree of freedom calculated from previous example I will talk to you like that. Okay. This is SP. You get that. Conventional. Okay. This is mu1 minus mu2. For this case, we check the analysis of weight of calcium in standard cement and cement not with lead. We would like to calculate percent calcium in the cement, right, for this. In standard cement and cement not with the lead, right, for this. Okay. We check confidence interval is equal to, right, this is what mean. This two mean is equal because it's negative and positive. We can conclude that a percent or amount of calcium in standard cement and in cement with the lead low in cement is equal. It's equal because the confidence interval includes zero for this. That's right. You can use the confidence interval to decide whether it's equal or not also. Right. Okay, I would like to stop the count. Continue for the next week.